Hey everybody, I am working the practice problems that you guys had for your rate of change homework assignment 1. And hopefully, by working these problems along with me and double checking yourself, it's going to help you out as you are working the rate of change homework problems 2. There are some pieces of background information that we need to make sure we remember in order for you guys to be successful on this homework assignment. The first thing we need to talk about is what exactly is a rate of change. And I'm just going to give you a quick reminder. Remember that when you have a table, your x value is going to be here on the left, for example. Your y value is going to be here on the right. Sometimes you will see your x value at the top of a table, y value at the bottom of a table if it's a horizontal table instead of a vertical table. But either way, no matter how it's listed, you're always going to follow the same process for finding the rate of change. Oops, it would help if I made this correct. Sorry, guys. Okay, so remember that your formula for your rate of change is going to be however much your y value is changing. I'm just abbreviating change in y. Remember, sometimes we also use the Greek letter delta to represent change, so either one of those is okay. So however much your y value is changing, set into a ratio over however much your x value is changing. So you can either say delta or change. I don't want this to be too confusing. Delta is a little bit shorter, so that's what I'm going to stick with for the majority of this video. I'm going to use delta, so your change in y over your change in x. So remember what we mean by that, our change in y. So literally, how much are our y values changing? So you're going to notice from here to here, I'm going up by 2. So my change in my y value is going to be a 2. And you'll notice my x value from here to here, it's going up by 1. So my change in my x value is a 1. So my rate of change for this particular table, my change in my y value over my change in my x value is 2 over 1. For our homework assignment today, I didn't specify whether you need to leave it as a rate or a unit rate. So as long as you have any possible correct version of this, I'll take it. So 2 over 1 is okay. You could have simplified it to 2 because I didn't necessarily tell you not to, although we did say that a rate is normally a comparison of two numbers. So this would be my preference for now for us to keep it at the 2 over 1. So that is how we found the rate of change from a table. Remember that when we've got a graph, it's exactly the same process. So let's say I've got a graph. I need to find my change in my y values over my change or delta in my x values. So I literally pick two places on the graph and I just see how much did it change. So up and down from here to here. How much did it change? Let's say I count and there's 1, 2, 3 places right here. So my change in my y would be a 3 as it moves from this point down to this point right here. It goes down 3. And let's say if I measure my distance right here, that this has a distance of 4. So this is my change in my x values, because remember your x is your horizontal axis, your y is your vertical axis. I know I'm going pretty quickly through this, so if you do need a little bit more in-depth review, like you really feel like you need a lesson, because right now I'm just kind of reviewing, please see some of the other materials, some of the other instructional videos that I have for you in the rate of change folder. Okay, so my up and down change, again, my change in y, or my delta y, is 3. My change in x, my delta x, however much my x is changing, is a 4. So that would mean in this case that the rate of change for this graph is a 3 over 4. Something else that we need for background knowledge that we discussed in class is that when a graph is slanting upwards in this direction, this is a positive, okay, or it's increasing. And then if it is sloping downwards, it's going to be a negative or decreasing. That's going to be important on one of your homework problems as well. Okay, and then the other piece of background knowledge that we need is finding the rate of change from an equation. And remember that an equation that represents a situation, x represents your independent variable, Y represents your dependent variable. It's the variable that depends on your x value. So this would be an example of an equation where you might see y depends on whatever x is. Okay, if x is 1, 3 times 1 would give you 3 for y. If x is 2, 2 times 3 would give you 6. So in other words, y depends on whatever your x value is. Remember that this coefficient, this number in front of the x, is how you find your rate of change. It has to be the number that is the coefficient in front of the x, not in front of the y, because the number in front of the x, in front of your independent variable, explains how your amount is changing. So that is how you would find your rate of change from an equation. So now let's take a look at some of those homework problems. So the first question says, which function has a higher rate of change? And what I'm going to do is I'm just going to pick two little spots right here on my graph where it crosses. I can tell that from my little tick marks, this is 1, 2, 3, 4 units up right here. Because remember, I've got to measure my distance from this point to this point. So if I'm going to travel from this point right here to this point right here, and I just picked those two particular coordinates because they're easy for me to see. Like visually, I can tell right here that it hits right there on a tick mark and right there on the tick mark on the axis. So it'll be easy for me to count. So remember that to find our rate of change, I do my change in however much my y is changing versus my change in however much my x is changing. So your y is your vertical axis, it's your up and down. I can tell from this graph because this goes up to the 4 right here. So if I'm traveling from this coordinate to this coordinate, I would have to travel down 4 places, and then I would have to travel over 2 places because this is here on the 2. So that means that rate of change is a 4 over 2. So my rate of change is 4 over 2. I am not going to be too concerned about, we're going to talk about the fact that it's decreasing, and that because we know from our review that this is going down, that means it's going to be a negative rate of change, which is a negative 4 over 2. I didn't specify whether you have to simplify it or not, so you could leave it as 4 over 2 if you want. You could make it a negative 2 over 1. We could make it a negative 2. Whichever one you want to pick is fine with me for right now. So, oh, oops, need to put my little negative there. So any of these answers would be perfectly fine. Okay, we need to compare it because this is asking which function has a higher rate of change. And so now we need to compare this rate of change, this negative 2, with the rate of change here in the table. And remember, for our table, it's the same thing. I'm going to have my change in my y values over my change in my x values. So I need to see how much is my y changing. So if I go from 2 to 8, that is going up 6. If I go from 4 to 10, that is also going up by 6. So this rate of change would be 6 over 6, which simplifies. I didn't say that we had to simplify it, but if you wanted to, it would be 1 over 1. Now, some of you might have noticed something a little bit peculiar right here, because if you look at your next interval, it actually is going down now from 8 to 1, so that's a change of negative 7. And then this one is changing from 10 to 3, so it's changing by a negative 7. But look, if you put your change in y over your change in x, so again, negative 7 over negative 7, you'll notice that negative 7 over 7 still actually simplifies to a 1 over 1. So no matter which particular set of values you chose to use to find your rate of change, whether you did 6 over 6 or you did negative 7 over negative 7, they both still simplify to the same rate of change. As far as which one has a higher rate of change, I'm going to actually take either answer right now. There is actually one correct answer that we are going to address at a later date. I will tell you that technically, even though it doesn't seem to make sense, this negative 2 is actually a higher rate of change. We'll explain why later. but we haven't actually talked about that reasoning yet. So if you look at it, the question says higher rate of change. If you look at it and you say, well, this one is a negative rate of change, while this one is a positive rate of change, so it means that this one needs to be bigger, I would accept that answer for now, even though technically, mathematically, and again, we'll do a more in-depth explanation of why later, the -2 is actually a higher rate of change, basically because it's changing more dramatically. This one is going down 2 for every 1 versus this one that is just going up 1 for every 1. So technically the answer should have been -2 because it's a more dramatic rate of change, but if you picked 1 over 1, if you picked the table because it's a positive rate of change, that's okay for now because your reasoning makes sense. Number 2, 3, and 4, we are asked to find the rate of change for each of these functions and in every single situation. Well, for these two, well, actually, we don't even need to do change in y for number 3. Sorry, I kind of digressed for a second. So for the table, I'm going to do my change in my y over the top of my change in my x. So I'm going to look here, and it's going from a -2 up to a +2. So that is a change of 4. This is going from 0 to 2, so that is going to be a 2. So I've got a 4 over 2. I did not specify how you needed to simplify it, so any way is fine by me. If you just left it as 4 over 2, if you simplified it to 2 over 1, if you simplified it to a 2, doesn't really matter. I'm fine with whichever one you decided to do. You'll also notice that if you didn't use this particular set of points, if you went right here to these, so from 2 to 4 increases by 2, from 2 to 3 increases by 1, your rate of change is still going to be a 2 over 1. So no matter which particular set of points you used, if you do your change in y over the change in x that matches, that goes with it, you're still going to get a 2 over 1. You're still going to get the same answer regardless of which pair of points you decided to do. Number 3. Sam has $75 in her piggy bank. Each week she saves $12 and adds that to her bank. What is the rate of change? Well, every week it is increasing by $12. So that $12 is how much her account is changing. Therefore, that is her rate of change. Number 4, real simple. Remember that this coefficient in front of the x represents your rate of change. So this 3 is our rate of change. You could also say 3 over 1, however you decide to do it, if you actually turned it into a rate. Either way, it's fine by me. Your x value is affecting, okay, it's changing by 3 every time your x changes. So that's your rate of change. Number 5, which one has the greatest rate of change? So I'm going to just kind of look, they both start at the same place. They both start right here at 0. And because I'm a visual person, I'm going to look right here at this spot, right here at the 1. So this line right here at the bottom, okay, this bottom line, if I move over 1, it's only increased up to 1. But then if I go up to this line, if I go over 1, it's actually increased by 2. So you can kind of tell, this is a visual, you can kind of see just by looking at it, that as it's changing, line A actually has the higher rate of change. And so when I say don't just say A or B, I'm saying that I really want you to give a reason for why it's line B. Okay, this is line B right here. You could say that the line is steeper, so it shows that it's increasing at a higher rate. You could say that if you go over, if they both go over 1, this one is just sitting at a 1, while this one is sitting all the way, looks like right here at a 2. That would be fine. But you could just say by looking at it that the line is steeper for line B. So that's how you know that it's a rate of change. It means that it is changing at a faster rate because it's a steeper line. It's a greater increase. So that would be an okay answer. Number 6, it says which equation has the same rate of change as this line right here as function. Don't worry, I'm going to explain to you a little bit later in the semester what this g of x notation means. Remember that the rate of change in an equation is this number, this coefficient, in front of the variable. So these numbers right here tell you the rate of change for each of these equations. So we need to see which one of these equations has the same rate of change as this graph. So what I would do is I would just pick a little point right here. I'm going to pick these two because they kind of hit in the corner, so it's kind of easy for me to see. So I need to do my change in how much my y is changing over my change in how much my x is changing. So my up and down change from this point to this point. If I look right here, now this is where us math people are trying to get you. It didn't just go down 1, 2, 3, 4. Notice my scale right here, that's not a 4, that's actually a 40. So my y change, or my delta y, is 40. If I go across, it goes across from 1 to 5. So my change in x is a 5. Which one of these is the same thing as 40 over 5? Yep, you got it right there. It would be the C. Number 7, what is the rate of change? Again, I'm just going to do change in y over change in x, or delta. It is increasing by 17 here. It is increasing by 2 here. So 17 over 2. You can leave it as 17 over 2. I didn't tell you that you need to make it a unit rate. If you decided to make it a unit rate, you should have gotten 8.5 over 1. Or you could have just simplified it to 8.5. Either one of those options would be fine, as long as I can tell you got it from doing 17 over 2. And last but not least, what is the rate of change? It's just this coefficient right here in front of the x. That gives you a -2/3 for your rate of change.